thank you to TTP for the opportunity to present our work in your tutorial today. So I'm going to talk about work that the guys on my team have been doing to apply the prototype of the dragonfly discovery really to applying design of experiment to factorial experimental design in order to miniaturize, automate and accelerate assay development and optimization. So just a little bit of background as to why we're interested in doing this. So as I'm sure you're all very aware, that the lead discovery process from identification of a target of interest through to delivery of a candidate molecule typically takes at least 3 years, I would say often a bit longer than that. And these days actually what we find is that in early discovery we have an increasing proportion of more complex phenotypic human disease relevant assays that we're trying to develop in the early discovery process. And we also have a higher proportion of unprecedented target classes that we're trying to prosecute. And all of those things mean that the assay developments that we're trying to conduct are actually more and more complicated, and there's a risk actually that the cycle times at that early stage can get longer and longer. So at GSK we have a goal of trying to reduce our overall cycle times from targets to hit. And one of the areas that clearly we control very readily in the assay development and screening space is how long it takes us to develop those initial assays. And that's where we think that application of this design of experiment, factorial design, and using very flexible liquid handling like the dragonfly discovery can be very impactful for us. So a bit of background on design of experiment. What is it? So it's the use of statistical models to evaluate experimental parameters in order to optimise your assay conditions in as few assay runs as possible to keep assay development time down, but at the same time to generate the maximum amount of information. So we have actually used DOE in the past in GSK. This is not a new concept, but to be honest it's been quite hard to gain traction in assay development and screening groups. And really the main reason that we found for this is because we had limitations in the liquid handling that we had available to us, both in terms of its flexibility and also in terms of the ability to dispense very accurately at low enough volumes for some of the miniaturised assays. And so that's where the collaboration with TTP around the dragonfly discovery prototype really came in. So TTP approached us with the instrument that they were developing, and we immediately saw that there was really great potential to apply this instrument for factorial experimental design, for all the reasons that Joby's already pointed out, but in particular for us because of the very wide dispense range that the dragonfly offers, down from 200 nanolitres up to kind of 4 mils, and also because it can deal with a very wide range of reagent classes. And the team have looked at dispensing anything from kind of typical aqueous buffers, glycerol, as Joby mentioned, all the way through to kind of organic solvents, and the system handles those just fine. The other key feature, which is very attractive to us, as again Joby mentioned earlier, was this integration with the statistical experimental design software JUMP. So really what you can do here is develop your assay protocol in JUMP. You can upload that protocol into the dragonfly discovery software. It helps you in terms of setting up those very complicated dispense protocols. You can run your experiments, export the data back into JUMP to complete complicated statistical analysis on your data. And all that can be done without any kind of copying and pasting of data, so you maintain data integrity throughout that whole process. So TTP were kind enough to put a prototype of the dragonfly into our lab at the end of last year for a few weeks. And so I just want to go through some of the top-level data that we generated while we had the instrument available to us. We started off just by looking at a couple of simple assay formats, really just to try and understand what the dragonfly could offer and how it compared to manual assay development process. So on this slide I'm just showing you data from a simple fluorescence polarization assay for a bromodomain containing protein. And so here what Louis in the lab did was essentially just run a KD determination manually and then compare that to the same experiment run on the dragonfly. And actually what you can see is that the data that he generated, so the manual data shown in red and the dragonfly data shown in blue, is almost identical in terms of the absolute result and the KD that he determined. But when you dig into the details of actually what he was able to do, so when he did this experiment manually, he had to do it in 384 well. It's very fiddly to try and do this kind of experiment in a 1536 well plate by hand. He did a 24-point serial dilution, which is typically what we do when we're doing a manual experiment like this. He did 3 replicates, which again is fairly typical of what we would do, and that took about an hour, so not a huge amount of time. But when you compare that to the dragonfly, here he was able to do that directly into 1536 wells. He could do more conditions, so we did 32 different conditions, more replicates of those conditions, so we did 8 replicates of each of those 32 conditions. And rather than a serial dilution, the dragonfly enabled us to do this as a discrete dilution, so we don't have any risk of carryover in that experiment. And on the dragonfly, that same experiment with more replicates, more conditions, took a third of the time, so just 20 minutes. So that data was really encouraging, so then we moved on to do a kind of complete assay development optimization on a time resolved fluorescence assay, again for a bromodomain containing protein. So here now we're incorporating the ability to use the JUMP software, so we designed the experiment in JUMP, imported that, as I said, into the Dragonfly discovery file converter, and what this gives us is a 1536 randomized dispense protocol that we can then set up on the Dragonfly. And so each colour here is representing an individual reagent that we're trying to optimise. So we're looking at 8 different conditions here that we're simultaneously optimising, anything from a buffer through to an antibody. And as Joby said, you can see the complexity of these dispense patterns that would be almost impossible to replicate manually. So this experiment was completed and then the data imported back into JUMP for the analysis. And what this enabled us to do is to actually complete that entire optimization of buffer, antibody condition, protein concentration for this TR-FRET assay in just a single experiment, so just one day, to essentially develop a biochemical assay. And again, the results that we obtained here, so we already had an assay set up that we could compare back to, and we got very similar conditions that we'd optimized to. So that just gives you a flavour of some of the opportunity there is with the Dragonfly in combination with design of experiments. Obviously, we're continuing to collaborate with TTP to look at more complicated assay systems. One of the advantages that Joby pointed out was that you can now take using the same dispenser, you can now take an assay through from development into screening. And so we wanted to again look at that for ourselves. And so that TR-FRET assay that we developed on the system, we then took through to do a small diversity screen of 1,400 compounds. We screened 3 sets, a small diversity, an interference set, and a focus set of bromodomain binders. You can see that the data quality is very high. We're getting Z primes of greater than 0.6. You can see that the data is very tightly clustered around 0, and that we're getting kind of hit rates that we'd expect for this kind of data. So all in all, it enables us to do this assay development very rapidly, progress straight into validation in a screening setting with no time taken to miniaturise the assay and no additional kind of readaptation to new automation. So that's where we are at the moment. I say we had the prototype in our lab for a few weeks. We're excited to get it back after it's gone through some additional development, and then we can do some more experiments. But really, I think the data that we've generated so far shows us that we're able to do miniaturised assay development on the system, and that means that it reduces our assay times and it reduces our reagent requirements. There's, as I said, decreased assay transfer bottlenecks because we're not having to re-miniaturise and re-automate the system when we move from one automation package to another. We've seen that the system gives us high quality screening data, very good data quality and reproducibility. And this capability of integrating with statistical experimental design really opens up a real opportunity for us to look at multifactorial biological experiments. And I think when we're looking at more complex assays, some of these cellular assays, I think that's actually where the biggest opportunity is for this. And so that's what we're hoping to explore further with TTP as we continue that collaboration. So that hopefully just gives you a snapshot of where we are. It's early days, so hopefully we'll be back to present more data as we generate it as the year goes on. Just like to thank my colleagues at GSK who've generated all of the data that I've shown you. I can't personally take credit for being in the lab and generating any of it. In particular, Pete, Michelle and Louis, who's a student in the lab. I should also thank Monique Thompson, who's sitting in the audience from our Philadelphia site, who's really championed design of experiment within GSK and helped us get this project going. And obviously our collaborators at TTP, who've helped us and been very open to the feedback that we've given as we've gone along in terms of the design of the instrument. Happy to take any questions. Yeah, so the experiments that I've shown here are just for binding experiments essentially, but yeah, I mean for a catalytic reaction, certainly the feature that Joby mentioned around the sort of incubation, so you walk away and still allow an incubation time course, that you could factor that in to your experimental design. Essentially time could be one of your parameters that you're trying to optimise, so yeah, definitely do it. Okay. It's 10 tips, right? Okay, brilliant.
Yeah, software manager often has a user interaction that point, so you can take one or two software and you run it and having to sit there and the next position, but because it's not compact, we will still play around with it and why we essentially in 50 rescue life. Still be good. So we're looking for a few more weeks partners over the next few months.
Yeah, the guys, I mean, so Pete, Michelle, very happy for, if anyone wants to contact them and get any information on how it's working for us, then they're very happy to do that.